Right, hello ladies and gentlemen, this is Mrs. Masteller once again. So in our next section titled 4-2, now we're going to be solving quadratic equations by graphing. So we know how to graph a basic quadratic, just graphing the parabola, but now how do we actually solve a quadratic equation by graphing it? So just to kind of reflect back, a quadratic equation, again, the standard form of a quadratic is just going to be ax squared plus bx plus c. So we're still going to be using all the tools and elements that we learned again in the previous section as far as graphing the parabola, but now we have to solve it. So how do we find the solutions? The solutions of a quadratic equation, they're called the roots. And the roots, one method to find the roots is to find what's called the zeros. And the zeros of the function are actually going to be the x-intercepts of its graph. And you can find the x-intercepts by simply graphing it. So the key thing to get down, first of all, is just knowing all this wording, because in the future, in the directions, if I'm asking you to find the zeros, if I say to find the roots, if I say to find the x-intercepts, they all mean the same thing. So just make sure you know this wording, that if I'm talking about the roots, if I'm talking about the zeros, if I'm talking about the x-intercepts, these all are the same thing. It's basically finding the solution. So the solution, or solutions, I guess I should say, I'm going to find the solution or the solutions to the function, again, which is basically, if you're talking about the x-intercepts, that's just a point where the graph crosses over the x-axis. So as an example, it says to determine the number of solutions, once again, that each one would have. So looking at the first one, if you look at the parabola, again, you're basically just trying to identify where is it crossing over the x-axis and how many times. This first one crosses, so this is our x, this is our y. This one's crossing the x-axis, we can see in 2 spots. So this one would have 2 solutions. Okay, the next one just basically touches at the vertex, it's touching the x-axis, and that's 1 spot. So this would just have 1 solution. And the last one isn't crossing whatsoever. It crosses the y-axis, but again, the x-axis, the x-intercepts is where my solutions lie. So since it does not cross over the x-axis, this would have no real solution. Okay, so notice too, I am saying there's no real solution. There would be imaginary solutions, which we'll talk about later on throughout this chapter. Okay, so remember the 5 steps to graphing a quadratic. So first, identify your a, b, and c. Okay, figure out what those are. Next thing is you want to find your y-intercept. So how do you do that? You plug in 0 for the x, and again, your c value is basically all you're going to have remaining when you plug in 0 for x. Next, find the axis of symmetry. So find that dotted line, and the formula is just x equals negative b over 2a. Next, once you know the axis of symmetry, you find the vertex, which is just going to be, again, the x-coordinate is negative b over 2a, then you plug in that value for x into the function to find the y-coordinate. You find f of negative b over 2a. Then ask yourself, is it going to go up or down, max or min? Up or down, max or min, as far as our vertex goes. Okay, then the last step is going to be to set up your table. You want a table of values. So when you set up your table of values, here's your x, y table. Again, your vertex goes in the middle. So once you got your vertex, you plug in numbers around your vertex, then just go from there. Okay, so something additional we're obviously going to be adding is solving, trying to find where it crosses over the x-axis. So here's our first example. Okay, so in the box, we'll just go ahead and label a, b, and c. So our a value is 1. Our b value is 4, c is negative 5. So first thing, our y-intercept, again, is just 0. And then our c value, which would be negative 5. Axis of symmetry, so do a negative b over 2a would be negative 4 over 2 times 1. So negative 4 over 2, we get x equals negative 2. So dotted line, going through x at negative 2. Okay, again, our parabola is going to be on that dotted line. So as I mentioned in the last section, where your axis symmetry is, you're not going to have a parabola like going somewhere over here now. Okay, so it should be on that dotted line. Our vertex, next thing, again, we have the x coordinate. We know it's -2, but now we got to solve for the y. Just take -2, plug it in everywhere you see an x. So we're going to have -2 squared plus 4 times -2 minus 5. So that'd be 4 minus 8 minus 5. So -4 minus 5, and you get -9. So there's our vertex. Is this guy going to open up or down? Is it going to be a max or a min for our vertex? It should open up because our a value is positive. So as long as you have a positive a value, should be opening up, which means you're going to have a minimum. So our vertex, that -2, -9, that should be the lowest point on our graph. -2, -9, here's our vertex. Again, nothing should be lower than that point. That's our minimum. Okay? Now, just plug in points around the vertex. So if you increase from -2, maybe you want to plug in -1 and 0. Other way, -3, -4. All right, so plug these points in for x, solving for the y. So if I plug in -1 for x, I'm going to have -1 squared plus 4 times -1, and then minus 5. So that would be 1 minus 4 minus 5. So that'd be -3 minus 5. I get -8. Okay, I'm just going to go ahead and copy it to the other side because, again, we get the same y coordinate on both sides. It's going to be reflective around the vertex. Okay, so if I plug in 0 for x, that should be pretty easy because that's just going to be our y-intercept. But I'll just go ahead and plug it in, show you guys the work anyway. 0 squared plus 4 times 0 minus 5. Well, you'd have 0 plus 0 minus 5, but that's just going to be -5. Okay, so let's graph this out so far just so we can get a visual going. So plotting these points, so my vertex, I'll start with that, going back 2 and then down 9 would be right here at this point. And then we have the point -3, -8, and then -1, -8. So again, it's going to be a mirror image on both sides around our vertex, around our axis symmetry. Going back 4, down 5, and then going 0, -5. So here's what we got. This is it. Okay, that little guy right there. Where now, again, keep in mind, we're trying to find the zeros. We want to know where exactly this thing's crossing over the x-axis. We can see it's going to cross, but where exactly we don't know. Okay, so my suggestion, if you run into this debacle, is add more points to your table. Again, we know it's going to cross, but we don't really see where exactly just yet. So if you keep adding points to your table, let's just say I plug in 1 and then -5. Hopefully at this point we should see it cross. Okay, so if I plug in, I'll just do +1. If I plug in 1 for x, let's see, 1 squared plus 4 times 1 minus 5. So 1 plus 4 minus 5, you get 5 minus 5, and that's going to be 0. Bingo, right here. These are our solutions. Okay, if I plot these next 2 points, graph them over here. So we got 1, 0 now, we got -5, 0. And we see exactly where it's crossing over the x-axis. We have the exact points. Okay, so as far as my zeros go, our zeros to this function would be +1 and -5. Okay, so those are our zeros, those are our roots, those are the x-intercepts, those are the solutions. Okay, and if you plug these numbers in for x, as you guys can already see, like I did back here with +1, if you plug that in for x into the function, you should get 0 for the y. So think about it like that. I'm finding the zeros. If you plug these numbers in for the x, you should get 0 for the y. Okay, the domain, again, for every single parabola is all real numbers. The range for this one, so my parabola starts down here at the vertex on the y, which is -9, and it's going towards positive infinity. Bracket around the -9, but a parenthesis around the infinity. All right, there's your first one. Not too bad, right? Again, doing all the same stuff we did in the last section, but now we're just trying to find where it crossed over the x-axis. So look at the next one. Again, we got a, b, and c inside the box, so this would be -2, -6, and then 5. So first thing, y-intercept, 0, c would be 0, 5. Our axis of symmetry, so -b over 2a, would be -6. Over 2 times -2, we get +6 over -4, which would be -1.5 is what we get. Okay, so we get a decimal. So -1.5 is going to be our axis symmetry. So dotted line going through x at -1.5. So right in between -1 and -2. That'd be negative 1.5. Finding the vertex. So if I plug in negative 1.5 for x, we're going to have, so it'll be negative 2 times negative 1.5 squared minus 6 times negative 1.5 plus 5. Okay, so evaluating this, negative 1.5 squared times negative 2, that's negative 4.5. And then negative 6 times negative 1.5 is positive 9 plus 5. So evaluating negative 4.5 plus 9, that would be positive 4.5, plus 9 more, we get 9.5. So our vertex is going to be, we have the x, again that's just from the x symmetry, and then 9.5 we get for the y. Okay, is this going to open up or down, making it a max or a min? So looking back at the a value, it's negative, so it should be downward facing, which means it's going to be a maximum. So that vertex that we just found, put in the middle of the table, negative 1.5, 9.5, that's our vertex. Again, that's going to be the highest point on our graph. Nothing's going to be above that point. Everything's going to be underneath it once it's all graphed and said and done. Okay, so now choose more points to plug in for x. You don't have to choose more decimals. Okay, I know we have a decimal for our vertex, but I'm going to choose some easier numbers. So if I go, let's just say a half, if I add a half from negative 1.5, I'd be at negative 1. If I subtract a half, I'd be at negative 2. So just choose some easier numbers after this. Okay, and then if I just add 1 now to negative 1, I'd be at 0. If I subtract 1 from negative 2, I'd be at negative 3. All right, so let's just see where this gets us. Hopefully we can find the zeros and where it's crossing over the x-axis. All right, so again, I'm going to plug in the easier numbers. I'm going to plug in negative 1, I'll plug in 0. Those numbers would be much easier to plug in. So I'm going to have negative 2 times negative 1 squared minus 6 times negative 1 plus 5. All right, so I was plugging in negative 1 for x. Here we go. So negative 2 times negative 1 squared would be negative 2 times positive 1. This would be plus 6 plus 5. So negative 2 plus 6 plus 5. So that would be 4 plus 5, and I get 9 as my output. So I should get 9 on both sides. Okay, plugging in 0 again should be easy. Negative 2 times 0 squared minus 6 times 0 plus 5. That's just 0 minus 0 plus 5. You get positive 5. Okay, so let's see where we're at so far. Let's just go ahead and plot these points and see if we're going to find where it crossed over the x-axis. So plotting these points, I'm going to start with the vertex. So negative 1.5, 9.5 is way up here. So kind of in the middle of that square. Okay, and then negative 2, 9 would be up here, negative 1, 9. So very close to that vertex. But our next 2 points kind of space it out a little bit more, 0, 5, negative 3, 5. So here's what we got so far. It's downward facing like we said. Okay, let me fix this curve over here that's going to bother me. Let's make this a little bit curvier. Okay, so we can see downward facing. Again, it is going to cross the x-axis, but we can't see the exact point as to where it's going to cross. So what we're going to do, go back to the drawing board, go back to the table, again, add some more points to it. Okay, I'm just going to add positive 1, negative 4, put some more points in your table. So hopefully we'll see it cross after these additional points. So if I plug in positive 1 for the x, so I'm going to have negative 2 times 1 squared minus 6 times 1 plus 5. So this would be negative 2 minus 6 plus 5, so negative 8 plus 5, and that's going to be negative 3. And that should do it. You can see how all of our y coordinates that we were calculating so far were all positive numbers, right? But you can see it jump, again, looking at the y's in particular, go from a positive now over into the negatives. This is where it's going to be crossing over the x-axis. Okay, in between these 2 points. So if we add these additional points over here to our graph, so let me just erase these arrows. We're going to extend this thing down now. So we just found the points again, negative 4, negative 3, and then positive 1, negative 3. All right, now we see for sure this thing's crossing over the x-axis. All right, let me fix this again. All right, that's better. Okay, so we know for sure that it is crossing the x-axis. Do we know the exact point? Not really. Okay, kind of eyeballing it, you can see this one might be, I don't know, might be 0.5. This one might be negative 1, 2, 3.5. Okay, it might be, but we don't know the exact point. We're going to be able to find the exact point later on in the future, but the fact that we're just graphing right now, we can't really tell where it's crossing. Okay, so again, it was where the y coordinates kind of switched over from a positive into a negative. So when it went from a positive to a negative, when it went from a positive to a negative, that's where it's crossing over the x-axis, which would mean it's in between these 2 points. It's in between these 2 points. So for right now, if you have a problem kind of like this, if you run across this problem, you would just simply say that it's somewhere between 0 and 1, and it's somewhere between -3 and -4. So we don't know the exact point. Again, it might be 0.5, it might be -3.5, but since we don't know the exact point just yet, this will just have to do for now. Okay, last little bit, again, domain and range. Domain is still all real numbers, negative, positive. The range for this guy, it is downward facing, so just be careful. As far as our range goes, technically, it starts at -infinity, works its way up to the vertex, which is where it stops, which is at positive 9.5 on the y. Again, the vertex y coordinate is positive 9.5. So my range would be from -infinity, is where it starts, and it goes all the way up to the vertex, which is 9.5, and that's where it stops. Okay? Once again, as usual, if you guys have any questions, anything, just let us know. Okay? But solving, again, you're just trying to find where is this thing crossing over the x-axis. You're just looking for your x-intercepts. Again, also referred to as the roots, the zeros, all the same stuff in the end. All right, but have a great day. Let us know if you have any questions. Adios.